So now let's learn about how to find arc length. So an arc length is a portion of the circumference of a circle. You can use the measure of an arc in degrees to find its length in linear units. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So we're going to use the measure of the arc in degrees to find the fraction of the circle. And then we're going to take that and multiply by circumference to find the measure of the arc length. So the total measure of the central angles of a circle measure 360. The total measure of the intercepted arcs of the central angle measure 360. So the central angles is equal to the intercepted arc. So we can use either central angle in degrees or intercepted arc in degrees to find the measure of the arc length in linear units. And let's look at a formula that makes this all clear. So you have the top part in your notes, and I want you to add the bottom part, because the bottom part I think is a nicer way to write it out and a nicer way to be able to reduce. So arc length is the distance along an arc measured in linear units. All right, so here we're measuring the distance from A to B. All right, so we're not looking at the curvature. We're looking at, if that was like a piece of string going between A and B and then we laid it flat, how long is that piece of string? We can find that, and this is the part I want you to write in your notes right here. All right, so first of all, I want you to add in that central angle equals its arc, because sometimes you're given the arc and sometimes you're given the central angle, and it doesn't matter because they're the same. AL just stands for arc length. So arc length is equal to the central angle over 360. This is the fraction of the circle. 360 degrees is the whole circle. The central angle over 360 gives you the fraction of the circle. We'll take that value and multiply by circumference, which is 2 pi r. To help you keep track of what's in the numerator and what's in the denominator, put that 2 pi r over 1, because 2 pi r is in the numerator. And then you will accidentally multiply it by the denominator. We're going to leave the answers as simplified fractions in terms of pi. I don't want to see a decimal, right? I guess if it were something like 5 halves and you made it 2.5, I guess that's all right. But we want exact answers, so leave these as simplified fractions in terms of pi, right? I'm expecting to see pi in the answer, all right? Do not multiply out by a decimal equivalent for pi, all right, and give me a decimal equivalent exact answers. And actually, it'll be a lot easier if you leave it in terms of pi. All right, so let's find the length of arc AB, and this one I know is in your notes. That we have the steps below there. The first step is to substitute the values of the central angle and radius in the arc length formula. This is the formula we're going to use all the time. Arc length equals central angle over 360 times 2 pi r. All right, so the central angle, and actually I'm going to write AB, so that's the specific arc we're finding. So the length of AB is equal to the central angle, which is 150 degrees, over 360, times the formula for circumference, which is 2 times pi times the radius. We're given that the radius is 5 meters, so we can plug in 5 for the radius. And the 1 helps me keep the right things in the numerator and the right things in the denominator. So step 2, I'm going to write this again. You don't have to. You can just reduce right where you are, but I want the original to stay for the notes. You can reduce within a fraction and from numerator to denominator when you are multiplying. All right, so first of all, what are some things I could reduce? Well, I see I got 150 and 360. They're both divisible by 10. I could cancel out those 10s. I see I've got 2 over here, and 36 is divisible by 2, so I could cross-reduce. All right, so 2 divided by 2 is 1. 36 divided by 2 is 18. All right, so 18 is not divisible by 5, so I can't cancel it with that one. But 15 and 18 are both divisible, both have a common factor. both of those numbers are divisible by 3. So I could divide 15 by 3, and I could divide 18 by 3. So, excuse me, I wrote 3 instead of divided by 3. So 15 divided by 3 is 5. And 18 divided by 3 is 6. And now we're going to multiply what's in the numerator. These are what we have left in the numerator. And we're going to multiply what we have left in the denominator. So that means that AB, the length of AB, is, I've got 5 times 1, that's still 5, and 5 times pi is 5 pi. 5 pi times 5 times 5 is 25 pi. Right? So I've got 5 times 1 times 5, right? That's 25, and then times pi. In the denominator, we have 6 times 1, that's just 6. There's our answer. 25 pi over 6 is the arc length, but don't forget your units. This is in meters. And that's it. All right, so after we reduce, we multiply values in the numerator together and multiply values in the denominator together. And that's all there is to it. All right, so let's do a few more. All right, we always want these, though, to be in lowest, we want these to be fractions in lowest terms. Right? Don't divide 25 by 6. Right? They don't go, it doesn't go in evenly. And don't multiply by pi. Leave it in terms of pi. All right, so let's find this one. We're going to find the length of arc AB. I don't think this one's in your notes. I'm not sure, but I don't think so. All right, so AB is going to be equal to the measure of the central angle, and the central angle measures 40 degrees, because we're finding the length of this arc here. And the arc is the same in degrees, right? This is also 40 degrees. So if we were given the measure of the arc in degrees, that's fine too, because the central angle and the arc are exactly the same. So 40 over 360 times 2 pi, and then the radius is 6 inches. And all over 1. All right, so I'm going to write it again, because I don't want to cross off the original, but you don't have to write it again. Mine gets saved, for other people to look at, and yours is for you to look at. So right away I see I can reduce the 2 zeros. And then I think 4 and 36. Well, 4 divided by 4 is 1, and 36 divided by 4 is 9. Can we reduce anything else? All right, so let's see. 9 is not 9 and 2 don't have any common factors, but what about 9 and 6? Well, 6 is divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So now we're going to multiply what's left in the numerator together and what's left in the denominator, and that's going to give us our answer. So the length of AB, is 1 times 2 times 2, that's 4. That's 4 pi. And in the denominator, 3 times 1 is just 3. So 4 pi thirds inches is the length of arc AB, and there we've got it. Another one done. All right, so these aren't too difficult. You do need to show your work on these, all right, because I expect to see the original. I'm going to wonder how you got to 4 pi thirds if you don't have the parts in there. You're not going to be able to look at that and do that in your head, all right, and I don't want you to. All right, I want you to write out the formula and then reduce, and then you have your final answer. All right, so you should have, and you could mark off, you could reduce right on the original. So you would have this one where you set it up and reduced, and this one, which is your final answer. If you want 3, you can have 3, but 2 is good. Let's look at the next one. All right, let's find the length of arc JK. This one's in your notes. Arc JK and arc JLK. All right, so JK. All right, so we see we've got the central angle there. All right, central angle, same as the measure of the arc in degrees. All right, so the length of JK is going to be the central angle, which is 60 degrees, over 360 times 2 times pi, and the radius is 16 inches. All right, so we set up our equation. Don't forget the 1 so that you make sure you multiply in numerator with numerator and denominator with denominator. And when you reduce numerator to denominator. All right, so let's see. I see the zeros. I can cancel those out. Oops, wait, sorry. I want to write it again so I have the original saved. All right, so JK equals 60 divided by 360 times 2 times pi times 16. All right, so we can cancel out the zeros. Oh, look at that. We got 6 and 36. They're both divisible by 6. 6 divided by 6 is 1. 36 divided by 6 is 6. 2 and 6, I could reduce the 2 and the 6. 2 divided by 2 is 1. 6 divided by 2 is 3. And now 16 and 3 don't have anything in common. So we've got a 1, a 1, a 16, and of course the pi in the numerator, and a 3 and a 1 in the denominator. So that means that the length of arc JK is going to be 16 pi thirds. All right, now let's find, I'm just going to move this up just a tad. I'm going to try. I guess that's, I don't even know where this one came from. Oh, that's the one that's circled. There we go. I'm worried about not having enough space. There we go. All right, so now let's find the measurement. Oh, they got any more extra space. Let's find the measurement of JKL. All right, so now we need to find the central angle. So the tape's going to pause. The measure of arc JK is 60 degrees. Tell me the measure of the central angle for JLK. All right, thanks for answering that question. All right, so together, JK and JKL equal the entire circle. They equal 360 degrees. We know JK is 60. If we subtract 60 from both sides, arc JKL is 300 degrees. So that's our central angle, 300 degrees. So we have 300 degrees, 300 over 360, the whole circle. This is the fraction of the circle, right? We want 300 over 360. That's how much of the circle we want, times the circumference, because all arc length is a portion of the circumference. So if you multiply the circumference by the fraction of the circle we want, right, we'll get arc length. Right, so 300 divided by 360 times 2 pi r, so that hasn't changed, it's still 2 pi 16. All right, and let's reduce. All right, so we could reduce, of course, the zeros. Could reduce the 30 and the 36. They're both divisible by 3, right? Both divisible by 6 too, aren't they? So 6 times 5 is 30, and 6 times 6 is 36. And we could reduce the 2 and the 6, right? 2 divided by 2 is 1. 6 divided by 2 is 3. And I don't think we can do anything else because 16 and 3 don't have anything in common. Now, the order you reduce in doesn't matter. I could have decided to divide by the 2 first, right? Maybe I cancel out the zeros and I divide by 2, and then I have 18, right? Well, 30 and 18 still have 6 in common, right? So it doesn't matter the order you reduce in, right? Just as long as you reduce from numerator to denominator. So we've got a 5, a 1, and a 16 in the numerator, and a 3 and a 1 in the denominator. And of course, the pi is also in the numerator. So that means that the length of arc JKL is going to be equal to 5 times 16 would be 80. So that's 80 pi thirds. Let's add those together. So if I add JK plus JKL, when I added the arcs, I got 360 degrees. What should I get if I add the lengths of the arcs? So JK plus arc JKL is going to be 16 pi thirds plus 80 pi thirds. And that would be 96 pi thirds. Well, I could reduce that. 9 and 6 are clearly divisible by 3. All right, so if I divide 96 by 3, that's going to be 32 pi. And that's inches. Hey, wait a minute. What's the circumference of this circle? So remember, circumference is 2 pi r. By the way, make sure you're taking notes on this one. This one's in your notes. I forgot to say that. Circumference is 2 pi r. The radius is 16. That's just 32 pi inches. So notice, since arcs JK and arcs JLK take up the entire circle, if I add those two arcs together, I get the circumference of the circle. All right, so all arc length is, it's a portion of the circumference. And the central angle over 360 gives us that portion. All right. I might stop after this problem and do the rest on the next video. Yeah, that seems like a good plan. Actually, let's do one more. We'll do one more and then I'll stop. All right, let's find the length of the red arc. This one's not in your notes. All right, so and it doesn't even have a name. So I'm just going to call it arc length. All right, so this could be point A and this could be point L. All right, so to find the arc length, we simply take the central angle, and remember the central angle and the arc are exactly the same. So if I'm given the arc in degrees as opposed to the central angle, doesn't matter. They're both the same. Central angle equals the arc. Matter of fact, I'm going to write that down here so we don't forget. Central angle equals the arc. All right, so arc length here would be 24 divided by 360 times 2 times pi, and the radius is 5 centimeters. I'll write that down there too. And I'm going to put that over 1 so I don't make a mistake when I'm reducing. And I am going to write it again because I want to keep that in my note, in the notes here. All right, so they're not both divisible by 10 this time, but I see we could reduce the 36 and the 2, right? That would, 2 divided by 2 would be 1. 360 divided by 2 is 180. Hey, 180 and 5, right? 5 and 180 are both divisible by 5. 5 divided by 5 is 1. 180 divided by 5. Let's see, 5 goes into 18 3 times. I've got 3 left over, so that would be 36. What about 12, 24, and 36? Well, you might think that they're both divisible by 2, and you'd be right. You might think they're divisible by 3, and you'd be right. You might think they're both divisible by 4, and you'd be right. Right? 4 times 6 and 4 times 9. You might think they're both divisible by 6, and you'd be right. 6 times 4 and 6 times 6. You might also think they're divisible by all those numbers. Maybe they're divisible by something larger, like a 12. And 24 and 36 are both divisible by 12. I'm just going to choose the largest, just so it doesn't get too busy up here. So 24 divided by 12 would be 2, and 36 divided by 12 would be 3. Now, what if you don't realize that they're divisible by 12? What if you just divide by 2? That's okay. You'd have 12 and 18. Right? And you might say, oh, wait, they're divisible by 6. All right, so I'll divide by 6. All right, 12 divided by 6 is 2. 18 divided by 6 is 3. Oh, there we go. So it doesn't matter if you don't divide by the largest value that they can be divided by, right? Because it'll work out in the end. You just keep reducing until you can't reduce anymore. So we have a 2, a 1, and a 1 in the numerator, and a 3 and a 1 in the denominator. And of course we have the pi also in the numerator. So the arc length here is going to be 2 times 1 times 1 times pi, and that's just 2 pi. And 3 times 1 is just 3. So that's 2 pi thirds centimeters. All right? Reduced form as a fraction in terms of pi. And don't forget your units. All right, we're going to stop here. And then on the next video, next Nearpod, we'll do a few more with arc length. Thanks for watching. Bye for now.